When we think about charged particles attracting or repelling each other, it's easy to imagine that an invisible force, something we call charging, is pulling us. But in the energy filament theory, the situation is much more complex than simply attributing it to a mysterious force. Instead, we understand that charge is the result of an imbalance in the tension along the inner and outer parts of a particle's loop. Let's use the example of an electron. The negatively charged particle has a tighter internal loop and a looser external loop, pulling the surrounding energy C inward, creating what we can think of as a tight C or compression. On the other hand, a positively charged particle creates the opposite effect, with the outer loop being more tightly wound and the inner loop more relaxed, pushing the surrounding energy C outward, forming what we could think of as a loose C or expansion. This distribution of tension, however, doesn't remain localized to the particles. It spreads out into the surrounding energy fields, forming permanent, directional textures. Imagine, for instance, the way a piece of cloth can develop wrinkles after being folded and left undisturbed for a long time. These wrinkles, in the context of energy filaments, are what we recognize as electric fields. These fields represent areas where the difference in internal and external tension is greatest. In the theory of gravity, we look at this as a tension slope, where the C moves from loose to tight. However, in electromagnetism, we look at a texture slope, where the energy C transforms from disorder to order. The smoother the texture, the smaller the overall distortion, meaning the path along the field is easier to follow. Now, when two charged particles come near each other, the interaction we observe isn't due to some invisible hand pulling them. Instead, the force we feel is simply a result of pre-existing, well-defined textured slopes that have already been imprinted on the surrounding energy C. As these particles move, the internal tension and texture have to be recalculated at every moment. The direction in which the inner loop and texture are best aligned is the path with the least overall distortion. This is why the particle naturally follows that path. The phenomenon we recognize as electric force is really the result of the particles moving along this energy-efficient path in the field. Now, let's take this a step further with the deeper aspects of electromagnetism. As we discussed in the second season, when a charged particle's internal loop begins to circulate, something even more fascinating happens. Instead of the particles simply following a straight texture, its path transforms as it begins to wrap the texture around itself, creating what we call a spiral. What was once a straight wrinkle becomes a circular or helical pattern that twists along the direction of movement. This is the complete electromagnetic field in action, where we observe the formation of spiral textures. When another charged particle enters this spiral texture, it's not just moving along a single path. It experiences two opposing forces. One force draws it along the straight direction, while the other slightly twists its path due to the circular nature of the spiral. These two forces combine to guide the particles along the most energy-efficient spiral path, making the particle's trajectory shift from a straight line to a curve and ultimately to a spiral. This effect, which we commonly recognize as the Lorentz force or the magnetic field, is simply the particle being guided along the path that minimizes its energy expenditure based on the overlapping texture slopes. To sum up the way electromagnetic forces work in the energy filament theory, electromagnetic force operates through the concept of a textured slope, while gravitational force operates through a tension slope. Both slopes essentially answer the same question: which path is the least energy-consuming? The universe, as seen through the lens of energy filaments, is a place where all particles simply follow the path that requires the least energy. They move along the easiest slope, as if sliding down a hill or rolling along a smooth path. This idea of the universe being guided by energy-efficient paths is a central concept in the energy filament theory, and it helps explain phenomena like gravity and electromagnetism in a completely new light. The forces are not magical or mysterious. They are the natural consequences of how energy fields behave when they are subjected to different textures and tensions. By understanding this, we gain a clearer picture of how everything in the universe operates. The next time you encounter a magnetic field or observe the effects of gravity, You'll have a better understanding of how these forces are simply manifestations of the underlying energy sea, constantly striving to minimize energy expenditure by following the most efficient paths. Tap follow, share it on New Physics, Clear Universe. Join us in our series of New Physics videos as we take you on a journey to see the universe in a completely different way.